Hello and welcome back, friends. Welcome back to another session on number system. So, if you have following this channel for some time now, you know we have done series of concept videos on number system. There are around 8 videos we have done. Post that we started focusing on the problems of number system, and this is the third session on number system problem. I'll link all the concept and the previous two problem sessions video in the description. You can have a look. Specifically, go back to the concept videos if you have not gone through them till now. Those are very critical, as you know, before we start diving into the problems. But like I always say, if you start with the problems, just don't go ahead and see my solution. You see the problem, pause the video, look for, try from your side for a couple of minutes. If you are able to solve, or if you are not able to solve, always come back and see the approach for solving this. So this is what, at a bare minimum, I would suggest to follow. And the other idea also, know that if we do around 8 to 9 problems in this session, you should do at least 25 problems. So 3x time per problem at home to completely gain mastery on number system. It's a little concept heavy area which requires practice. So that's why we are doing this focus 3-4 sessions on number system problem. In 4 sessions together, we'll do something around 30-35 problems, something close to, yeah, 35 to 40 problems. You have to do at least around 100 problems on number system to get an understanding of that. Any doubt, anything, please feel free to drop a comment in the description box or mail me. We can take it forward. So let's get started for today's session. So today's session will be primarily on remainder theorem and finding the last digit or problems around like that. So that's where we will do most of the problem solving for today. So let's say, so this is, let's start. So the first problem is that find the last digit of these two. So we know there is, just a minute. Yeah. So 73.37 plus 37 to the power 73. So these are the two things they have said, right? So 73 to the power 37, what will be the last digit? So the last digit will be same as 3 to the power 37 and here 7 to the power 73, right? Because the last digit, you know, always it's the last digit. So let's say I'm taking for an example, let's say 14 to the power 14 square. It is the same as last digit as 4 square. 14 square is 196, 4 square is 16. So the same last digit. You take any random value. Let's say you take, let's say I'm just taking an example, random example. Let's say 11 to the 11 cube. What is the last digit of 1 cube? 1. 11 cube is 1331. So, you know, the last digit of any number is basically this way you can find out that is basically if you focus on the unit digit of that number and the power, that is only your focus area should be. So 3 to the power 337, we know 3 has a cyclicity of 4. So after every 4 digit, 4 power 3 is replaced. So what is 3 to the power 1? 3, 3 square 9, 3 cube 27, 3 to the power 4, 81. And 3 to the power 5 is 243. And then it goes on. It repeats this, the last 3 digits, 3, 9, 7, and 1. At every 4 interval, and same with 7. You can check with 7 to the power 1 is last digit 7, 7 square last digit for 9, which is 49, 7 cube last digit 3, which is 343, 7 to the power 4 last digit 1, 7 to the power 5 last digit again 7. So it also has a cyclicity of 4. So can I write 3 to the power 37 is nothing but 3 to the power 4k plus 1, or 4 to the 4k is 9 here, and 7 to the power 73 is also nothing but 4k plus 1, because 73 is what? 72 plus 1. 72 is multiple of 4. So it will be falling back to same 3 to the power 1 plus 7 to the power 1. So 3 plus 7, your last digit will be 0. Okay, so 3 to the power 4k will have the same 3 to the power 4k plus 1 will have the same last digit at 3 to the power 1. 7 to the power 4k plus 1 will have the same last digit at 7 to the power 1. So 3 to the power 1 and 7 to the power 1 is nothing but your 3 and 7. So then the final last digit will be 0. Yeah. Okay. Let's move to the next problem. What is said in the second one? The second one says 237 to the power 256 into 625 to the power 729 plus 294 to the power 333. This is same as saying 7 to the power 256 into 5 to the power 729 plus 4 to the power 333, right? So 7 has a cyclicity of 4. 256, is it a multiple of 4? Yes, it's a multiple of 4. So 7 to the power 256, if I can write 7 to the power 256, we'll have same last digit as 7 to the power 4. 7 to the power 4, we have seen here, the last digit is 1. So this is 1. 5, I know always 5 square 25, 5 cube 125. 5 will always have a last digit of 5, whatever be the power. So 1 into 5 plus 4 to the power 333. 4. This I can write it as 332 by 4. If I do, what is the remainder? So it is, so this is 4 to the power 4k plus 1. You can write 4 to 333 can be written as 4k plus 1. So then I can write this is as 5. And 4k plus 1 means it will have the same last digit as 4 to the power 1. So 5 plus 4, 9 is the last digit we are looking for. Okay. So again, bitting, it's basically the two things that we learned from here is the cyclicity and how to use them. Please go through the concept video of last digit that we did in number system. This will be really helpful for you to understand this. But I'll just quickly give you a recap. Your cyclicity is very important. So if the cyclicity is 4, then every fourth digit, every fourth power, after every fourth power, your last digit will be same as the one that was before that 4 power. So 4 to the power 4k plus 1 will have the same last digit as 4 to the power 1. 4 to the power 4k plus 2 will have the same last digit as 4 square. So that way. And the cyclicity. And the next important thing we have learned is 73 to the power 37 will have the same last digit as 3 to the power 37. So it's the unit digit which matters, not anything else. So unit digit to the power whatever the exponent is given to you. So that's where you should be focusing on. So 73 to the power 37, to write 3 to the power 37 is a learning, and how to use the cyclicity. These are the two things we have learned across this problem. Okay. Any doubt, please drop a note in the comment section or mail me. We'll be able to guide you. So let's go to the next problem. It's an interesting problem. Find the last two digit of 149 to the power 324. Let's see what do I mean by last two digit. So if a number is divided by 100, okay, let's take a step back. How we can find the last digit? We know there is a formula, but if there is a number divided by 10, it will always give you the last digit. Think on this. Any number you take in the world, you divide by 10, you will always get the last digit. The remainder that remains, last digit is the remainder. So the same thing, if any number in the whole world, if you divide by 100, you get the last two digit is the remainder. So if you any number in the whole world you divide by 10, you get the last digit as a remainder. If any number in the whole world if you divide by 100, you will get the last two digit as a remainder. Now we know there is a formula for like we know the cyclicity for last digit that we have used in the previous problem. But apart from that, if you can divide that number by 10, you will still get the last digit of that number. But for the last two digits, let's try to divide this by 100 and see what's the remainder. So 149 3 to the power 24, let's say divide by 100. Okay. So can I write this as 100 plus 49 whole to the power 324 by 100? Okay. Now, if you know this formula, and again, I'm just using this. So a plus b whole to the power n is written as a to the power n plus a to the power n minus 1 into b plus a to the power n minus 2 into b square plus a to the power n minus 3 into b cube, and so on. Finally, you get b to the power n at the end. So this is the formula of a plus b to the power n. Now, if I can use this, we can write this as 100 to the power 324 plus, this is NC1 actually. So we can write this as, just a minute. Write this. Okay, so there's a small change in that formula. A to the power n plus NC1 a to the power n minus 1 into b plus NC2, which is the combination, a to the power n minus 2 into b square plus so on. And finally, we'll get b to the power n. So in this case, we will get 324 C1 into 100 to the power 323 into 49 to the power 1 plus 324 C2 100 to the power 322 into 49 square. So that's way we can do this. Now, if you see until the last one, 49 to the power 324. Now, if you see this carefully, this is nothing but your n to the power. If you think this carefully, this is nothing but till the last term, every term will have 100 attached to it. 100 to the power 324, 200 to the power 1. There will be 100 attached to it in each term. So each term of this particular series, I can say, is completely divisible by 100. So if I divide this whole thing by 100, every term will be completely divisible by 100 apart from this last term. So it will be remainder of 49 to the power 324 by 100. Or in a way, we can say, if we look for the power, think on this. If we look for the power of 14, last two digit of 49 to the power 324, that is the last two digit. I look for 49 to the power 324, that is my last two digit. The last two digit is 49 to the power 324. Again, 4 as a cyclicity, you know, this is basically boils down to 49 to the power 4. Okay, this is 49 to the power 4k plus 4. Or I will say 49 to the power 4k itself here. So this is nothing but 49 to the power 4k. So 49 to the power 4, whatever be the last two digit for that. Since it is last two digit, that's why you understand this. You may think, okay, let me tell you, you may think till now that in the single digit last digit problem, we took the only last digit and took. So in this case, if I have to find out the last digit, I'll just do 9 to the power 324. In the case of two digit number, what I'll do, I will take the last two digit and take the power, see the power of, and what's the value. So 49 to the power 4k, 49 to the power 4k is same as 49 to the power 4. Okay, it's the same way of calculating 49 to the power 4. If you do this, you will get the last two digit as 01. So 01 is my last two digits. 49 to the power 4, this is the only part you need to calculate, but it's 49 to the power 4 as the last digit of 0, 1. Okay. 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 Let's move on to the next problem. So what we learned from the previous problem is when it's a 2-digit number, you take the last 2 digit and take the power of the take the power, and when it's the last 1 digit, you take the last digit and calculate for the power given to it and find the last digit of that particular number. When it's 2 digit, take the last 2 digit and calculate for the power. And I also give you a small understanding of how to do a polynomial a plus b to the power n and how it to be written and how that can be applied for a higher number. Okay. Now let's see what is said. 3 to the power 116 divided by 28. Okay. Now if I do 3 to the power 1 divided by 28, just okay. Let me see. I know 3 to the power 1 divided by 28 gives me a remainder of 27. Sorry, 3 gives me a remainder of 3. Now think on this. If I do 3 cube, which is 27, that divided by 28 gives me a remainder of 1. And if you recall the remainder theorem, we said, or you need to always look for numbers which gives you a remainder of 1. So 3 to the power 116, if I have to write in a power of 3, that will be written as 3 to the power 114 plus 2. 114 is basically power of 3. So can I say this is 3 to the power 3k plus 2? Or not 3k, let me write it as 3 to the power 3 into 28 plus 2. So can I write this as 27 to the power 28? Not 28, it's 38. Yeah, 38. 27 to the power 38 into 3 square. Okay. 3 cube is 27, so 27 to the power 38 and then into 3 square. Okay. Now, so this is same as 3 to the power 116. Now 27, if you divide by 28, you will always get a remainder of -1. You will get a remainder of -1. So it's not 1, it's -1. 28 divided by 27, you give a remainder of -1. So this, again, let me write it that way. So I'll come back to the 3 square part later. So this divide by 28 separately, this divide by 28 separately. Now again write 27 to the power 38. Let's see what it becomes. 28 minus 1 whole to the power 38. Now if you recall this particular formula that we have written here, a plus b whole to the power n. If I can write it back here, in our case, what I will write? 28 to the power 38, that is a to the power n, minus 38c1, 28 to the power 37 into 1 to the power 1 plus 38c2, 28 to the power 36 into 1 square plus 38, minus here. So minus 38c3, 28 to the power 35 into 1 cube, and so on. The last value will be 1 to the power 38. The last value will be 1 to the power 38. Okay. Now, think on this. You have, and this is a very important part of this. So you have 1 to the power 38. Then how many terms you have here? So if I have a plus b to the power n, normally a plus b to the power n, there are total n plus 1 terms. Okay, n plus 1 terms. So out of 38, that means I will have 39 terms. In this case, I will have 39 terms. In this 39 terms, I see the minus sign comes in the second term, then in the fourth term. So every even term, there is a minus sign. Okay. 1 to the power 38 will be the last term, or I can say the 39th term. This is 39th term. So for 39th term, there will be a plus sign before that. So for every even term, I can see a minus sign. For every odd term, I can see a plus sign. That's the difference between a plus b to the power n and a minus b to the power n. So a plus b to the power n, all terms are positive. A minus b to the power n is the alternate terms are negative. N minus 1 b to the power 1 plus nc2 a n minus 2 b square and so on. Okay. So its alternate terms are negative. So the alternate terms means even terms are negative. 1 to the power 38 is the 39th term, which is the odd term. So that will be a positive. So 27 to the power 38, your last term will be 1. Okay. So now coming back to this part, what we are saying 27. So remainder of 27 to the power 38 divided by 28 is nothing but 1. Okay. Now you have remainder as 1. Now, if we know the remainder as 1, then what is 3 square? Remainder of 3 square divided by 28 is 9. So 1 into 9 divided by 28, you get a 9 as a remainder. So your final remainder is 9. Why the plus and minus was important? If it is a minus 1 as a remainder, then minus 1 into 9 is minus 9, and your actual remainder was 28 minus 9, 19. But here you get a plus 1, so then there is no problem, chance of a negative. 1 into 9 is 9, 9 divided by 28, remainder is 9. So you understand the difference of a negative remainder, and then what is the actual value of the remainder. So if, like I said, if 30, instead of 38, you would have 39 in the power, then 1 to the power 39 would have been a even term and carrying a negative sign to it. So then your remainder of 27 to the power 39 divided by 9 divided by 28 would have been minus 1. Minus 1 means your remainder is 27. Okay. So 27 or minus 1 here, and then you have a 9 as a remainder, right? So you have a 9 as a remainder. So minus 9 is your remainder. Minus 9, minus 1 into 9, minus 9 would have been your remainder. And then if you calculate for minus 9, you would have got 28 minus 9, 19 as the final value. There is a change, would have been a change if the remainder was plus 1 in this case. But if it is a minus 1, your remainder would have changed. So that's what the understanding of plus minus is very important. But the idea is if you get a higher power and a composite number at the, or a composite or a prime number at the denominator, so try to see which power of the given number is giving up plus or minus 1 as a remainder, and then you go forward from there. Okay, let's move to the next problem. Find the remainder when 29 to the power 177 divided by 21. Now 29 is anyway more than 21, so I'll right away. Just a minute. Hope it's visible. It's visible. So 29 to the power 177. Let's straight away write it as 21 plus 8 whole to the power 177. Now, if I have to extend this 177 plus 177 C1 21 to the power 176 into 8 to the power 1 177 C2 21 to the power 175 8 square and so on. So, and finally 8 to the power 177. Now, if you see this very carefully, every term apart from this last term carries 21 with it. So then the term will be whole divided by 21. So 29 to the power 177 is finally boils down to remainder of 8 to the power 177 by 21. Okay. 8 to the power 177, 21. Now, if I do 8 to the power 177, 8 to the power 177, I can write this as so 21, if you see 21 3s are 63 and 8 square is 64. So if I write 8 to the power 8 square into 2 into 1 long 88 plus 1. That is same as 177 divide by 21. I can say this is 64 to the power 88 by 21 into 8 to the power 1 divided by 21. This is where we need to focus on the remainder. Okay, 64 to the power 88 can easily be written as 63 plus 1 whole to the power 88 by 21, and this is 8 to the power 1 by 21. Now 63 plus 1 whole to the power 88, like in this case, you know, till the last term 63 will be attached to it, and then the whole thing will be divided by 21. Final term will be 1 to the power 88. So in this case, it will be 1 to the power 88 divided by 21 into 8 to the power 1 divided by 21. Okay, so this we can write the first. So in this case, the remainder will be 1. 1 to the power 88 is 1, so the remainder will be 1. In this case, the remainder will be 8. So 1 into 8, 8 is your final remainder. See how we can break it. 29 to the power 177, we broke it to 21 plus 8. Then we focus on only 8 to the power 177. 8 to the power 177, we further know 21 3s are 63 and 8 square is 64. So that's where there is a 1 plus 1 ka gap is created. So then we convert that 8 square into 8 squared into 2 into 88. So that means till 68 to the power 176, it is completely divisible with a remainder of 1. So 68 to 8 to the power 176 becomes 64 to the power 88. 64 is 63 plus 1. And we finally focus on 1 to the power 88 by 21, which gives a remainder of 1. So till 8 to the power 176, I have a remainder of 1. Then the last 1 8 is remaining. That when divided by 21 gives a remainder of 8. So 8 in remainder in the second case, 1 remainder in the first case, our final remainder is 8. Okay, see the approach, how we are breaking it into smaller blocks and looking for a gap of 1. And that's where we are getting the most of the answers. Let's move to the next problem. Okay, this is a little different problem. Let's try to solve it differently. So 23 cube plus 24 cube, 25 cube plus 26 cube. Now these are typically cubes. So let me see, if I do 23 plus 26, it gives me 49. I'm just trying to think. And 24 plus 25 is also 49, and 98 is 49 into 2. Let's see if we can get out something of that. So if I break it, so 23 cube plus 26 cube plus, I'm just grouping them right now. So this part is A plus B. Okay, A plus B into A square minus AB plus B square. Similarly, here also 24 plus 25, 24 square, 24 into 25 plus 25 square. Okay. Now the first part is 49 in the first case, and in the second case, the second part is also 49. Okay, so we can take 49 common. Can take 49 common from here, and then the next part is 23 square minus 23 into 26 plus 26 square plus 24 square, 24 into 25 plus 25 square. Okay, this is what we have got till now. Now, if you see this very carefully, so this is what we got is a multiple of 49, which is 49k. Let's say this part, this whole part is k. Let's say, okay. So 49k is what we got. Now we know 49, if k is odd, then 49 divided by 98, you have a remainder of 49. You try doing it with any particular odd value of k, you will always get a remainder of 49 when divided by 98. But if I know if k is even, then 49k divided by 98 will always be a remainder of 0 because it is completely divisible, because k is 2, 4, 6, whatever, you just need 49 into 2. So every higher value of even values of k apart from 2 will be divisible by 98. So if k is even, all 49k will be divided by 98 fully. If k is odd, then the remainder will has 49. So let's see if I can find out if the value inside is odd or even. Okay, so 49. Let's see the first part. What is 23 square? 23 into 23. Odd into odd will be odd. 23 into 26. Again, odd into odd will be odd. And then finally you have 26 square, which is even. Odd, odd, even. And then finally, what you have? 24 square. 24 square will be even. 24 into 25 will be even. Okay. 24 into 25 square will again be odd. So if you have this, sorry, this will be a minus. It doesn't matter basically in odd even calculation, your plus and minus will act in the same way. Okay. So now you can see in a sum of odd and even number, go back to the basics. In a sum of odd and even number, the number of odd numbers determine what will be the outcome. So you have 3 odd numbers, so your outcome will be odd. So 49 into odd. So here a is odd, your outcome is odd. So the remainder will be 49 when divided by 98. Okay, so see how we got it. We now see the individual values, which is odd, which is even. So basically, if I am dividing by 98, I know 49k when k is 1 or any odd number as per matter. By dividing 98k, we'll get a remainder of 49. If k is even, 2 or any higher even number, you will get a 0, or it will be completely divisible by 98. Now we just see what is the value of k, whether it's odd or even. We just applied 23 square is 23, 23, so it will be odd or into odd. 23 into 26, your odd into even. So this will be even. 26 square will be even. So okay, this will be even. This will be even. 20 yeah, 24 square. 24 square is even into even, so even. 24 into 25 odd into even, so even. The final one is even, right? My bad, in this case it is not odd. I did a small error previously calculating 23 into 26 as odd. It is actually a even. So your final one, you have 2 odd numbers, so the outcome will be a even number. Like we know, in a mixture of even and odd number, the number of odd numbers matters. So you have 2 odd numbers, so outcome will be a even. So you have even number of odd numbers, so outcome will be even. So your remainder is not 49. Your remainder will be 0. It will be completely divisible. Okay. Let's move to the next problem. Set k to the power 47, 141. So we know k to the power 47 factorial plus 141, which we can write it as 47 factorial plus 3 into 47. Okay, now what is 47 factorial? 47 factorial is nothing but 1, 2, 3, 4 till I have 47 plus 3 into 47. Okay, now I have, let's take the first one, 3. So 3 I have in the first part, 3 I have in the second part. So 3 is completely divisible. It is completely divisible by 3 because 3 is there in 47 factorial also, 141 also. Let's take the second one, 47. Now, if I take 47, 47 also is in the first part, is also in the second part. So this is also divisible. Let's take the third one, 94. So for 94, I have to have 94 in both the cases. So in the first case, I can get 47 and 2 multiply and get a 94 as a factor out. But in the second case, I will not have a 2. I will not get a 94. I will get 47, but it is multiplied with 3. So there is no 2. So I will not get 94. So 94 is not possible. Let's take 141. So in the first case, again, I can do 47 and 3 multiplication and get 141 out from the first one. And the second one also has anyway a 141. So 141 is coming out of both the terms. And that's why 141 can completely divide 47 factorial plus 141. So 347 and 141, all of these can divide the given term, which is k. But 94 is not, because there is no 2 in the second term, which can be multiplied with 47 to give you 94. Yeah. Move to the next problem. N is a single digit prime number which leaves the remainder of 4 when n cube minus 1 is divided by 8. Very basic. You can start with any number. Let's say n, I take the first prime number. I'm doing some trial and error to show you. Single digit prime number. What are the possibilities? 2, 3, 5, and 7. These are the 4 possibilities. Single digit prime number. Now 2 cube minus 1 is what? 2 cube minus 1. So 2 cube minus 1 is 7. 7 divided by 8 does not give a remainder of 4. So this is not possible. 3 cube minus 1 is 26. 26 divided by 8 does not give a remainder of 4, gives a remainder of 2. 26 by 8 gives a remainder of 2. So this is not possible. Let's see for 5. So 5 cube minus 1 is 124. 124 by 8, yeah, it gives a remainder of 4 when divided by 8. Okay. So 5 is the only scenario. Let me show you for 7 also. 7 cube minus 1 is 342 by 8. 342 by 8. It also does not give a remainder of 4. It gives a remainder of 4 8 is 32, 2 gives a remainder of 6. So this gives a remainder of 6. This is also not possible. So this is the number we are looking for. So what is the remainder when n cube plus 1 is divided by 7? So n cube plus 1 means 5 cube plus 1 divided by 7. So 126 divided by 7. And it is 0 as a remainder. 0 remainder. Because this is completely divisible by 7. Okay. So this is another different type of problem we did. So we did a lot of remainder problem, the last 2 digit kind of a problem, and how to find out whether a higher power of a number is divided by a particular number or not. That we did. We will do more problem of remainder theorem in the upcoming session, and that will be the last session of number system problems. But please go through the concepts, and hope you find this session useful. Go through the earlier videos, try at least 20 problems of this kind at home, and then you will completely able to master this topic. This is a very, very important area for your CAT, NMAT, SNAP, IFT, whichever exam you look at. Okay. So see you next time. Please feel free to like, share, subscribe the channel. That's the only motivation. We make these videos completely free for you. And yeah, do reach out to me or drop a comment if you need more help. See you next time. Thank you. Bye.